Hello students, welcome to PK's Learning Station. Today we are going to discuss Superposition Theorem. What is Superposition Theorem? The Superposition Theorem, the network should contain the linear element. So the condition is the circuit must have more than one independent sources. You have to keep one source at a time. Calculate the given question. Then keep the another source, find the same, and finally you have to add all the values. For example, for in this problem, our question is to calculate the voltage V0. We are going to calculate the V0. First, you want to keep a 10-volt voltage source. At the time, you have to remove all other independent sources. You have to keep only 10-volt voltage source. You have to remove this 5 amps current source. You have to find out V0. Then same, you have to remove this 10-volt voltage source. You have to keep this 5 amps current source. Find a V0. Then finally add both the V0. That is your actual V0. Okay. So remember in the superposition theorem, keep one source at a time. Other sources are removed. Keep only one independent source at a time. Other independent sources are removed. How to remove the independent sources? How to remove the independent sources? So it is very important. So first one, voltage source. How to remove the voltage source? Voltage source. When your voltage source becomes a zero at the time of short circuit. When you are short circuiting the terminal, your voltage will be zero. Your voltage will be zero. At the time of short circuit, your voltage will be zero. So if you want to remove the voltage source, then terminal of your voltage source should be shorted. Next, second one is current source. Mostly there is only two independent sources, voltage source and current source. So what to do the current source? The current source, when the current source becomes a zero, when your circuit is open. When your circuit is open. If you want to remove the current source, then the current source terminal should be open circuited. Open circuited OC and S. So now we can see we have to do a Superposition theorem here. Okay. So you have to do a two independent sources. You need to do two times. Okay. So 2 V0 you have to find out. First, I want to keep a 10-volt voltage source. I should redraw the circuit. 10 volt, 2 ohm, 4 ohm, 8 ohm, 2 ohm. Now, this is current source should be open circuited. This current source should be open circuited. Okay. This current source should be open circuited. Got it? So, this is the current source. The current source is removed by open circuit. What is the voltage value? 10 volt, 2 ohm, 4 ohm, 8 ohm, 2 ohm. What is the voltage? I will keep the voltage as V01. So for keeping only 10 volt, right, I will keep the V0 as V01. Okay. How to solve this? You can solve as your choice. You have if you are familiar with mesh and nodal analysis, you can apply any one, mesh or nodal, you can find out your V01 easily. So here I am going to apply mesh analysis because the voltage source is present. I will be compatible with mesh analysis matrix method. Okay. So how many meshes? This is the one mesh. I will assume the current as I1. This is the mesh 2, current I2. But now this is not a mesh because it is open. There is no current flow here. Okay. So this problem only two meshes. This problem only two meshes. What is the equation for mesh analysis? R into I, which is equal to V. The mesh analysis R into I is equal to V. R is a square matrix. The size of the matrix R is depending upon the number of unknown mesh current, number of meshes, two meshes. So the R size is 2 cross 2. Current matrix is column matrix 2 cross 1. Voltage matrix also column matrix 2 cross 1. Okay. Now what is the matrix now? So 2 cross 2 matrix. So what are the diagonal elements? So this is your mesh 1, right? The mesh 1 direction is this, this, this. What are the resistors? There 2 and 4. Add both the resistors. 2 plus 4. Coming to the mesh 2, what are the mesh 2 current resistance? 8 ohm, 2 ohm, no resistance 4. So 8, 2 and 4. 8 plus 2 plus 4. Then off diagonal. What is your off diagonal? So we can see here there is a 4 ohm resistance in the off diagonal, right? Because you have to identify the resistance which is carrying both the mesh current I1 and I2. So the 4 ohm resistor was carrying your I1 current as well as I2 current. But I1 current is so top to bottom, I2 current is bottom to top. Both are opposite, so minus of the resistance. And what about the voltage? So for this one, we're going with this way, right? Going in upward direction. Second sign is plus, potential rise. Second sign is plus, potential rise. So mesh 2 doesn't have any voltage source, 0. So here it will come I1, I2 only. Here what is the current? Mesh current I1 and I2 only. Yes. What are the current I1 and I2? We have to calculate the current I1 and I2. So we have to take two unknowns. Yes. Now 2 plus 4. 2 plus 4. Then minus 4. 10. Minus 4. 8 plus 2 plus 4. Then 0. Your current I1 is 2.06 amps. 2.06. Your I2 is so your I2 is 0.59. 0.59 amps. So these are the I1 and I2, right? Now what about your V01? What is your V01? The V01 is nothing but voltage across 8 ohm. According to the Ohm's law, according to the Ohm's law, what is the current flowing here is I2, right? The current which is flowing through this 8 ohm resistor is I2. So as per the Ohm's law, V is equal to IR, or I is I2, resistance is 8. So 8 into 0.59. What is my V01? So 8 into 0.59. The voltage is 4.72 volts. 4.72 volts. This is V01. Then we can go for the second case for keeping the 5 amps, removing the 10 volt. Okay, keeping the 5 amps, removing 10 volt. Yes. Going for the second circuit. Going for the second circuit with the help of 5 amps current source. We want to redraw the circuits now. Now this 10 volt voltage source should be removed by short circuit. Removed by short circuits. Then we have a 2 ohm, 4 ohm, then 8 ohm, 2 ohm, 8 ohm, 2 ohm, 8 ohm, 2 ohm. What is the current source? 5 amps. The current source is 5 amps. The circuit, right? So how to draw the circuits now? So I want to keep a 5 amps now. Then the 10 volt will be removed. The 10 volt is the voltage source. How to remove the voltage source? The voltage is removed by short circuit. In the remaining 2 ohm, 4 ohm, 8 ohm, everything is as it is. Now what is the voltage equation is? V0. This is for the first case V01. This is the second case V02. Okay. Now we can apply any method. So I will be compatible with nodal analysis. This is a node A. The voltage is VA. This is node B. Voltage is VB. What is your V01, V02? So here is V02, right? The potential difference between the two terminals. VA minus VB volts. This is your V02. Okay. Now we can go for finding the matrix. I will write it in the matrix form. So how to write the matrix for nodal analysis? For nodal analysis, the matrix structure is 1 by R into V is equal to I. What is the size of 1 by R matrix? It is a square matrix depending upon the number of nodes. 2 nodes and this same is a ground node. Ground node. Okay. So it is the size is 2 cross 2. The voltage is column matrix 2 cross 1. The current is also a column matrix 2 cross 1. Right? Now we have to form a matrix now. Current. So VA and VB. Okay. Yes. What are the values now? Now the node A have a 3 resistance 2, 4, 8. So 1 by 2 plus 1 by 4 plus 1 by 8. 1 by 2 plus 1 by 4 plus 1 by 8. Next for the second one. Only 2 resistance 8 and 2. So 1 by 8 plus 1 by 2. The node 2 have only 3 elements. Out of 3, 1 is the current source. Leave it. Only the resistance should be taken reciprocal and 1 8 is the one resistance 1 by 8. 2 is another resistance 1 by 2 we can add. Next off diagonal. What is off diagonal? What is the resistance between the nodes? 8 ohm. Minus 1 by 8. Always negative. Minus 1 by 8. Yes. What about the current value? So node 1 doesn't have any current, right? Node 1 doesn't have, node A doesn't have any current source, 0. The node 2 have a 5 amps current source. The 5 amps is entering, so plus 5, right? So what are the values of V1, V2, V3? Sorry, VA and VB. What are the voltages VA and VB? Solved by grammar rule or matrix method, or you can use equation mode. The values are 2 inverse plus 4 inverse plus 8 inverse, then minus 8 inverse, 0, minus 8 inverse, 8 inverse plus 2 inverse, then 5. The voltages are 1.18 volts, then 8.24 volts. Yes. What is our V0? V02 is VA minus VB, right? Where V02 is VA minus VB. What are the values of VA? 1.18 minus 8.24. What about V02? It should be a negative, right? It should be a negative. Yes. So 1.18 minus 8.24. So the value is minus 7.06 volts. Yes. Finally, what is the V0? Your final answer, right? Your final V0 is equal to V01 plus V02. This is what is your V01? Your V01 is 4.72. Your V01 is 4.72. V01 is 4.72. 4.72. V02 is minus 7.06. Now the actual voltage also will be a negative. 4.72 minus 7.06. The answer is minus 2.34 volts. Minus 2.34 volts. So this is our final V0. So in next video, we are going to discuss about the Thevenin theorem. For the same problem, we are going to solve by Thevenin theorem. At the time, we want to verify it, whether we are getting the same V0 minus 2.34 is getting or not. We will check it. Okay. So if you have any doubt in your superposition theorem, so kindly give it to the comment window. So thank you for watching this video. Thank you for all.